everyone, and welcome to our lecture 1, which handles data classification. And of course, in this lecture, we are going to have a number of issues to discuss, and among those, we are going to look at the meaning of data classification, what we talk about here, the key definition of data classification, and then we shall look at the importance of data classification. And then we shall look at the different forms of data classification. We shall look at the frequency distribution as one of those forms of data classification. And then we shall wind up our discussion with activity 1, which we shall handle in a different lecture video. So straight away into our lecture, we bring in the key definition. We want to understand what is data classification. So on the following slide, we are saying that data classification refers to the process of grouping data, which is usually raw data, into classes of common characteristics and attributes. So what we do, we group our data after collecting this data from the primary sources. We group it into classes, which we believe that in these classes we have data with common characteristics and attributes. We continue the second block by saying that the different classes created will comprise of data that has similar attributes and characteristics which are of interest to the investigator or researcher. I can give an example here, assuming that you are a researcher, you're researching about different nationalities, and you find that in the people that you're collecting data from, they have different races. For example, you find that there are those that are black and there are those that are white. So in arranging that kind of data, you put those people that are white in one class and those people that are black in another class. So in that way, you will have different classes created, different classes created, which will comprise of data that has similar attributes and characteristics. And of course, again, if you find that in the same data you have Ugandans, you have Kenyans, you have Sudanese, so you can group those individuals in different classes which may be associated with the countries of origin. You put the Kenyans in one class, then you put the Ugandans in another class, and so on and so forth. Again, I can give another very, very common example of ages. You may find that there are people that are from 10 years to 20 years, others are from 30 years to 40 years. So they may have different characteristics. For example, if someone is 10 years, they will not have the same attributes as a person who is 30 years, for example. So it would be very, very wise to classify that data into different classes. So the following slide, of course, brings out the importance of data classification. And in the slide we are saying that data classification is of importance as it helps in meeting the following objectives. We have 3 major objectives here. And then number 1, we have rearranging of data. We are saying that when faced with a mass data classification will help in reducing such data to some kind of order that is manageable. So in that way, you are able to rearrange your data and you'll be able to manage your data very, very well. Number 2, we are talking about data processing. We are talking about data processing, and here we are saying that data classification is one of the first steps towards data processing, which is a process of converting raw data into more meaningful form. So you find hardships if you don't classify your data when you are processing it. So for you to be able to make your processing of data easy, you need to classify that data. And of course, we are saying data classification is that very, very first step that you're going to make when you are processing your data. And then finally, in the following slide, we are saying that data classification is of importance because of the features and the parameters. And here we are saying that data classification helps application of statistical models which are employed to bring out the different parameters or the features of data. Most of the statistical models do not support data that is not classified. So you find yourself that you need to classify your data for you to be able to use some of these models that we are going to discuss in our quantitative techniques lectures. All right, so we ask ourselves, what are the different forms of data classification? How can I classify my data? So on the following slide, we bring out the forms of data classification, and in the slide we are saying that there are two major forms of data classification, and those are qualitative data classification and quantitative data classification. Those are the two major forms. We can classify data qualitatively, we can also classify data quantitatively. So on the following slide, we look at qualitative data classification, what it is all about, and we are saying that data that cannot be measured quantitatively, mathematically, is classified according to its attributes such as color, sex, and age. And we continue by saying that such data is usually descriptive in nature, and only its presence or observance can be noticed. We continue by saying that qualitative classification of data can be simple, dichotomy, or manifold. Okay, so I can simply say it can be simple or complex. Of course, we shall see all these ones as we go into qualitative and full discussion on qualitative data classification. All right, we proceed to look at the quantitative data classification, what it is all about. And here we are saying data that can be measured mathematically or statistically can be classified quantitatively using class intervals, tables, or what we call the graphs. Data that can be measured mathematically or statistically can be classified quantitatively using class intervals, tables, or graphs. We continue on the bullet by saying that such data can be assigned statistical units that are measurable. So in this way, we don't use attributes that like those we have seen under qualitative data classification. Here we classify data by assigning it some statistical units. They could be kilograms, they could be percentages, they could be liters, and so on and so forth. So we continue by, of course, looking at the different ways we can present our data. After looking at how data can be classified, we look at the different ways in which data can be presented. And on the following slide, we are saying that data can be presented in a number of ways using the following tools. So these are the tools that are examinable in paper 2. 1, we have the frequency distribution. Number 2, we have the histograms. Number 3, we have cumulative frequency distribution. Number 4, we have cumulative frequency polygon. Number 5, we have percentage OGIF, or what we may call the smooth T OGIF. All right, we can't cover all this in this lecture, so we shall mainly cover the frequency distribution, which is a very, very important tool that is used in the presentation of data, how we present data to those that need to make use of it. So the frequency distribution is a very, very important tool, and here we are saying that when we are faced with a mass of data to be analyzed, the very first step is to reduce the data to some kind of order. So we continue the second bit by saying that grouping of data into suitable classes is a way of constructing a frequency distribution. So table 1 shows an illustration of a frequency distribution. I'll be making use of this table. I've presented my table here. So this is my table 1, which shows a typical frequency distribution. So in our discussion by, of course, looking at the different elements that make up our table. So when you look at our table here, it has that column that captures the class. So we shall see those class limits. It has this column that captures the class boundaries. It has this column that captures the class mark, and then this column that captures the frequency. So in the following slide, we are saying that the elements of a frequency distribution include the following. The examiner may examine this, so you should need to know. One, we have seen that one of the elements of a frequency distribution is the class limits. Then we have the class boundaries. Then we have the class width. Then we have the class mark. And then finally we have the frequency, as you have seen in our table right here. We have the class and then the class limits. Okay, we have the class limits right here. We have the class boundaries. We have the class mark and the frequency. So we are going to first of all discuss one by one to understand exactly what these are all about. So in the next bit, we are looking at the class limits. Slide, we are saying that class limits are the smallest and largest observable data events in each class. Class limits are the smallest and largest observations in each class. So we continue by saying that each class has two limits, the lower class limit and the upper class limit. Each class has two limits. We have the lower class limit and the upper class limit. So we are saying that the lower class limit of a class is the smallest data value that can go into the class, whereas the upper class limit of a class is the largest data value that can go into the class. When you look at our table here, we have the class limits in this column, and as you have seen, each class, these are all classes, 10 to 19, 20 to 29, 30 to 39, they all have two limits, the lower class limit and the upper class limit. So all the figures that begin here are lower class limits, and all the figures at the end are what we call the upper class limit. So we are saying the lower class limit of a class is the smallest data value that can go into the class, whereas the upper class limit is the largest data value that can go into the class. So when you look at our table here, for example, the class of 10 to 19, this class here, 10 to 19, includes only those marks which fall in the interval 10 to 19. Okay, the class 10 to 19 includes only those marks which fall in the interval 10 to 19, 10 and 19 inclusive, that is to say including 10 and 19. Similarly, if I also select 30 to 39, if I select 30 to 39, 30 to 39 class includes only those marks which fall in the interval 30 to 39, 30 and 39 inclusive. Okay, so and so on and so forth for all the other classes. 60 to 69 will include only those marks which fall between 60 and 69, including 60 and 69 itself. All right, so in this case we shall say for the classes I've selected here, 10, 30 and 60 are the lower class limits, whereas 19, 39 and 69 for the classes I've selected here are what we call the upper class limits. Okay, are what we call the upper class limits. Now to continue, number 2, we have mentioned that class boundaries are also an element of our frequency distribution. Class boundaries are also an element of our frequency distribution. So we want to understand what are class boundaries. So here we are saying class boundaries is a concept in statistics that refers to the boundary between one class or group of numbers in a distribution and the next class. Class boundaries is a concept in statistics that refers to the boundary between one class or group of numbers in a distribution and the next class. As you have seen in our table here, the classes are very close to each other. We have 10 to 19. Now from 10 to 19, we have 20 to 29. So to try and create a boundary, we create what we call class boundaries. So the class boundaries are going to help us to separate one class from another. Okay, the class boundaries are going to help us to separate one class from another. So in the slide we are saying in our notes here, we are saying that the raw data in table 1 suggests that the marks were recorded to the nearest whole mark, which means that the marks in the class 10 to 19, for example, should only be those marks which are greater than 9.5, or what we may say 9.5, and less than 19.5, okay, or 9.5. So it is going to help us to create a boundary between the different classes, so that we are very, very sure that we are not putting figures that belong in one class into the next class. So that is all about the class boundaries. So as I've mentioned here, if I make use of this table, how do we get the class boundaries? You may be wondering, how do we get the class boundaries? So what we do, for the lower class boundaries, we subtract 0.5, okay? So if you subtract 0.5 from 30, definitely you get 29.5 for that particular class. And then to get the upper class boundary, we add 0.5 to the upper class limit. So in that case, if I add 0.5 to 39, I'll be getting 39.5. So you proceed to determine all the other class boundaries in that way, by deducting 0.5 from the lower class limit and then adding 0.5 to the upper class limit. So those are the class boundaries. Next, we have the class width, okay? And here we are saying the class width is the difference between the lower and the upper class boundaries. We may also define the class width as the class size. So if someone talks about class size, it's the same as the class width. Thus, in our example, the class width will be determined as follows. For the class 10 to 19, okay, for the class 10 to 19, it's going to be 19.5, okay, it's going to be 19.5 minus 9.5, and that definitely gives us a class width or class size of 10. Alright, we have discussed the class limits, the class boundaries. So as you can see in our frequency distribution, we have the column capturing the class mark. So we want to understand what are class marks. So we continue in part D by saying that the class mark is the midpoint of a class interval and is obtained by adding the lower and the upper class boundaries and dividing the sum by 2. So we are saying that the class mark is believed to be the midpoint of our class interval. And how do we get the class mark? We shall add the lower class boundary to the upper class boundary and then dividing what we get by 2. Thus, it means that the class mark for the interval 50 to 59 is going to be our 49.5, which is the lower class boundary for 50, and then 59.5, which is the upper class boundary for the 59, divided by 2. So when you make use of your calculators, you see that 49.5 plus 59.5, we get a figure of 109. So to get the class mark, we shall divide that total by 2, and definitely if you check your calculators, you see that we are getting a figure of 54.5. Getting a figure of 54.5. Finally, we have the frequency. And of course, when you look at our table 1, we have included the number 100 at the end of the column for frequency. If I just take you to our table here, you'll see that we have included this 100 here. Okay, so these are the frequencies, and those are the observations that fall in the different classes we have created. So of course, we are saying in our notes here, that this number, the total, is the total obtained when all the frequencies are added up, and this serves as a check on whether you may have made an error in tallying the data. The sum of the frequencies must be exactly equal to the total number of your observations. So if the students are 100, your total frequency should also be 100 for that matter. Alright, so that is our very, very first discussion on data classification. So we move into activity number 1. Now in this activity, we have these marks, okay, for 45 examinations, and we are required to make a frequency table starting with less than 40 to 49. So the video that presents the solution to activity 1 is in a separate upload. Okay, there's a separate video that goes into the solution to activity 1. So I want you to go to your account. If it has not yet been uploaded, to be coming in a few hours from now. And then again, I need to mention that for now we are covering data classification, but the notes up to measures of dispersion have already been uploaded, and the videos that explain all those notes should be on your account by Friday, in 3 days time from now. In 3 days time we are working on the videos, so they should be coming on. And then we have also agreed that at the end of a given number of units we shall be having a live Zoom lecture where you may be able to ask different questions where you did not understand from all the videos you've had. So for now, you can go to your account, pick the notes that we keep on uploading. We are uploading the notes according to the timetable, and then the lecture videos usually follow the notes within 3 to 2 days. So you keep on checking your account to see which videos have come on, so that you continue to read as you're being guided in this lecture. So for now, I'll leave you to go look at the activity, and then we can proceed to explain how we construct a frequency distribution table.